We are continuing with rates of change, part 2. If you missed part 1, go back and check that out, where we talked about tangent lines and secant lines. So here, when we look at rates of change, we want to look at comparison of slopes, first of all. If you think about these 4 different looking slopes of lines, one thing that's important, even though it might be somewhat simple from algebra, is you want to recognize positive, negative slopes, zero slopes, and when slope is undefined. So this is a positive slope when you're going up as you're going left to right. This is a negative slope as you're going down from left to right. This is a zero slope with a horizontal line, and this would be undefined slope when you have a vertical line. So those are all going to be important when we're talking about the derivative, because remember we said the derivative is the slope of a tangent line or a slope of a curve. So when you look at this curve, we have positive slope, then we have negative slope, we have positive slope and negative slope. And you can see that will help us find these local max and min points on the curve. If this helps, give a like and subscribe. Now we can also talk about concavity, which is how rates of change. So in other words, if we look at this concave up and this concave down, these slopes will actually be increasing here. The slopes would be decreasing here. If you look at the slopes, this is like a steep negative slope. And then you get a negative slope that is less negative, and it's increasing up to a zero slope, and then it continues to increase to positive slope and steeper positive slope. Or on the concave down situation, you have a positive steep slope. It's getting less positive as it goes towards zero, and then it starts getting more negative, and so in other words, the slope continues to decrease. So here you have rates of change that are increasing, and here you have rates of change or slopes that are decreasing. Now connecting this all to calculus, we use the first derivative for slopes. So when a first derivative is positive, the slope is positive. And we use second derivatives for concavity. So when the second derivative is positive, we have concave up. When the second derivative is negative, we have concave down. So there's a glimpse into some of the calculus of this with the first and the second derivatives. If this helps, give a like and subscribe.